ladies and gentlemen. Today we are looking at my favorite lesson in systems of equations. It is elimination. So what we're going to look at first is how to get the screen to focus. And we're going to look at the equation on the far left, 4x plus 6y equals 32, along with 3x minus 6y equals 3. Now what you will notice is that these two equations are set up in the same way. You will notice that we have the x terms first, followed by the y terms, followed by an equal sign, and then constants. Now, the reason this is important is we want to look at if we were to add or subtract the top equation to the bottom equation, would anything eliminate? And what we would notice is that there is a plus 6y with a minus 6y. And if I were to add them together, I would have no y's remaining. So elimination is a method where we get rid of a pair of terms right off the bat, and then we add the rest of them together. 4x plus 3x is 7x. 32 plus 3 is 35. And then we solve. In this case, I would divide both sides by 7 and get x equals 5. And very quickly, I have my first variable, which is like, wow, this is great. Now I need to pick one of the two original equations. Doesn't matter which one. So in this case, I'll take the first one, 4 times 5 plus 6y equals 32. And I'm going to simplify one side so I get my two-step equation, and then solve my two-step equation in order to solve for the other variable. And so at this point, very quickly, I eliminated one variable, solved for the other, and then substituted back into an original equation and got 5, 2 as the solution to my system. So we'll try it a couple more times. I always use highlighters when I do it and make sure that I am partnering things that have the same variables or are both constants. And that way I know when things are going to eliminate. So for example, if I add the first equation to the second equation, this negative 4x and this positive 4x will cancel. I will add a positive 3y with a negative 5y for negative 2y. And if I add the constants, I get a 2. Divide both sides by negative 2, and I very quickly have my value for y. So if y equals negative 1, I can then substitute that back into either of the original equations. Now, I'm going to pick the second one because the 4x is positive. It actually doesn't matter which one you use. So I'm going to have 4x minus 5 times negative 1 equals 5. Now, this is the only thing that might hang you up. It's a negative 5 times a negative 1. So 4x plus 5 equals 5. I'm going to subtract, because it was a plus 5, subtract 5 from both sides. And don't get weirded out. We get x equals 0 all the time. The 5 minus 5 was 0. Divide by 4 is still 0. So I would have 0, negative 1 as my solution. Last but not least, sometimes you will see that the thing that cancels has no coefficient at all. So 2x and 3x, those are not going to cancel. If I look at a positive y and a negative y, those coefficients are 1s, so it's a negative and positive 1y. So those are going to be the ones that cancel. Once you've got that, add the rest of those together. 2x and 3x makes 5x, 10 and 5 makes 25. Divide both sides by 5, x equals 5. That's nice and quick. And then I have to make sure that I substitute that x equals 5 into one of the two original equations. Doesn't matter which one, I'll take the first. So 2 times 5 plus y equals 10. 10 plus y equals 10. And when I subtract 10 from both sides, I can get this one even faster because y didn't have a coefficient. Y equals 0. So my solution in this case would be 5, 0. So that's not terrible. We really like the elimination method. If it works, we choose it. For this method to work, you have to make sure that the coefficients for one of the variables are opposites. So for example, on this one, the positive 6y with the negative 6y. In the case of the next one, when I get it to focus, it is a negative 4x with a positive 4x, and last, a positive 1y with a negative 1y. 3 times a number plus 7 times another number is negative 1. Negative 3 times the first number plus 5 times another number is negative 11. Find the two numbers using a system of equations and elimination. So first I want to pick variables. You can pick whatever variables you want. Your variables don't need to match my variables, but you'll notice that there are two separate sentences. And those two separate sentences both end with is and then a number. So you can see that this one ends with is -1, or you could see it if I could get it to focus. And the second one ends with is -11. So that word is, don't forget, that tells us where the equal sign goes. 3 times a number, so I'll just use n, plus 7 times another number. Well, I just know it's a different number, so I can't use the same letter, so maybe I'll use m. 3 times a number plus 7 times another number is or equals -1. So that's my yellow sentence. 3 times a number, 3n, plus 7 times another number, 7m, equals -1. The second equation from the second sentence, -3 times the first number. So first number I was using n, -3 times the first number, plus 5 times another number, plus 5, another number I was using m, is or equals -11. So I can very quickly tell that the 3n and the -3n, that's going to be my elimination, the part that cancels. Now when I add these two equations together, 7m and 5m are going to be 12m. -1 and -11 combined is -12. Divide both sides by 12, and I'm going to get m equals -1. I can substitute m equals -1 back into either of my first two equations. 3n plus 7 times -1 equals -1. I chose the first equation. Instead of the m, I put the -1 there. 3n minus 7 equals -1. Add 7 to both sides. 3n equals 6, and divide both sides by 3, I get n equals 2. Now this was a word problem. So when you get here, you are almost done. The last thing you need to do is just answer the question. Find the two numbers using a system of equations and elimination. I used elimination, I used a system. The two numbers are 2 and -1. And you could have put them in the other order and that would have been fine as well. I just remembered up here 3 times a number plus 7 times another number. N was the first letter that I used, so N was 2. I listed that one first in my answer.